We're live. Okay.
Hi everyone. Are we live?
Yeah, we're live. We should be able to be live. Let me check YouTube. So yes, we are live. People are watching. So yeah, hey everyone, welcome.
Hi everyone, and welcome to our very first edition of Nairobi GraphQL Meetup. Thanks for tuning in. I'm Joey. I'm joined by Mahmoud from the Prisma team. This is a collaboration, myself and the Prisma team. Thanks for tuning in. So today we are going to have two talks. The first talk will be joined by Julian, where he's going to be talking about generating queries using GraphQL JS, the library. Then the second one, we are going to do some kind of a live coding thing, where we are going to show you how to write your resolvers using Prisma. And then we also giving away a book by Marc-Andre production Ready GraphQL. So all you have to do is fill in your details, and then the winner will be picked at random. So be sure to check out the chat, fill in your details, and then by the end of the meetup, one lucky winner will be walking away with that book. Cool. Just
Awesome.
check out the chat. Maybe Mahmoud, do you want to say something?
Yeah. So hi, my name is Mahmoud Abdelwahab. I work as a developer advocate at Prisma. And Joey is a Prisma ambassador. So he's been very active in the Prisma community. And yeah, this event is an example of his contributions to the Prisma community. And yeah, if you want to check out, go to prisma.io/ambassadors, I believe. Like, let me check that. And yeah, for the raffle, we're giving away the book Production Ready GraphQL. And I'll send a link for this type form. You're just going to complete it and go through this type form. So we can just do a random selection, and you might win like at the end of the live stream. So stay till the end. And yeah, I would say you, Joey, you can keep you can just say what happens next now.
Cool. So I think without further ado, we're going to invite Julian. He's going to tell us a bit about himself, and then he's going to present his slides.
Okay, so let me bring Julian to the stream.
Hi everyone. Thanks so much, Joey. I'm glad to be here. It's such an honor to join you for this first GraphQL Nairobi meetup. And yeah, I'm going to be talking about generating GraphQL queries. I'll share a bit more once I'm sharing my screen, but yeah, I hope to inspire you to build the next great GraphQL tool with my talk.
Great. Take it away.
Sure, I'll share my screen and I'll start. Let's see, I'm sharing my screen now. And you should be looking at the title of the talk, which is Dynamic GraphQL, from types to ASTs. There's a website URL with the talk, so feel free to check it out. And there's also my Twitter handle there, which is hard to show when links are underlined. It has some underlines first and last. But let's get started. First of all, yeah, I'm Julian. I'm so glad to be here. And I need to say I'm kind of addicted to GraphQL. In what sense? I love to build stuff with GraphQL, stuff that helps you build stuff. So mainly tools. I wrote an open source book about GraphQL a couple of years ago. Been working at GraphCMS, which is a headless CMS that provides a GraphQL API since 2018, so some years ago. And on the side, I also build stuff with GraphQL. There's API Live, my side project, which lets you build internal apps with GraphQL. And I also have some weekend hacks. For example, a no-code UI for GraphQL APIs, which is called GraphQL Admin. So I'm kind of like GraphQL. You could say I'm addicted. Yeah, so that's all nice, but what is this talk about, you might ask? And I'm glad you did, or I did. So first of all, I'm going to dissect some popular tools in our GraphQL ecosystem to maybe guess a bit about how they work and how they leverage dynamic GraphQL queries and schemas. Then I'll share some tricks I've learned over the years writing this type of code that generates GraphQL queries and schemas. And lastly, I really want to encourage you to build the next one. We all love these tools, and you have all that it takes to build the next one. So a couple of prerequisites. Just a heads up, this is not a hardcore technical talk. I won't delve deep into code because that's hard, and you should do that after the talk because I will inspire you and give you some general tips and tricks. But still, you need some basic familiarity with GraphQL. So let's define some things first. So what's GraphQL? It's a transport layer tool to build APIs and clients. There are many definitions, but use it mainly to build APIs and clients. And there is a thing called a GraphQL schema, which is basically a lot of types describing the data that you can query. Like, here's what the API gives the consumers. And that takes us to what's a GraphQL query. And I would say it's a document describing what to get. So that's what the clients use to say, hey, this is what I need right now from the API. So you select a bit of it. And now we can get started. I call this standing on the shoulder of giants. And I'm going to be taking a look. I look at some GraphQL tools and maybe try to guess how they handle dynamic GraphQL. Let's start with Prisma, which are the hosts of this meetup. Let's ask 3 questions about it. Like, what is it? It's a database ORM. And but I don't really like acronyms. I think they're great, but they need more explanation. So what does that mean? It makes querying databases that easy. It's really easy. It's a great tool. I use it on my projects, and it really simplifies querying data, inserting data, and migrations. So how does it use GraphQL, right? And I'm sorry, Prisma people. I don't work with the Prisma inside of Prisma, so this is just a guess. And feel free to correct me after the talk. So how does it work? You write some simple Prisma schemas, and Joey will dive deeper into that on the next talk. So don't worry if I go through it too fast. But you write this really easy to write and readable Prisma schemas. And I guess it converts them to GraphQL schemas, giving you a nice type-safe SDK to interact with databases. So I think that leverages GraphQL. Again, this is just a guess, but it's also a nice thought exercise of how can you use GraphQL in there. So it converts those functions into GraphQL queries. And having GraphQL queries is a great middle step to generate the final SQL queries. So as you can see, it can leverage dynamic GraphQL by creating schemas, creating queries, and transforming those queries to SQL. Now let's take a look at another tool, GraphCMS. This is where I work. It's my 3rd year there. What is it? A headless CMS, a GraphQL headless CMS. And like, without acronyms now, it basically gives you a nice drag and drop API builder, so you can build your sites with your favorite tools. And it also gives editors a nice UI to manage all the content. And how does it use dynamic GraphQL? Well, when you are on the drag and drop builder and you perform actions, create models, create fields, it generates a GraphQL schema on the based on your actions. So you have a fully fledged GraphQL API without writing any code. And there's also that content editing experience, which it creates by leveraging that GraphQL schema that you generated dynamically. And it shows a UI on top of it. So it creates queries and a UI on top of them. Now let's take a look at Apollo client. I'll take a look at 4 tools. This is the 3rd one. What is it? Declarative data fetching client. And I didn't use any acronyms there, so I guess I could give a bit more of an explanation. So it basically makes front-end developers' data requirements really easy. It's super easy to interact with GraphQL APIs. Just describe what you need, and then it handles fetching that. And how does it use dynamic GraphQL? Well, the code is open source, so feel free to check it out. It's really cool, really well written with a lot of tests. But one of the cool things that it does is that it gets a GraphQL schema, and it creates, it normalizes that data into a client-side cache, which you could use to have offline queries, to have optimistic responses, a bunch of cool stuff. And so a cache uses, you can customize this, but the cache is a key value store, basically, in memory key value store, with the types and IDs of your data and the values. And lastly, let's take a look at Gatsby, which is used to be a static sites generator, but you can basically create a bunch of dynamic sites, and it provides a lot of great tools for that. And I didn't use any acronyms there as well. So it really allows front-end developers to build really performant sites and applications. And it uses GraphQL heavily. It creates a GraphQL schema at build time. So it's really cool because it creates that GraphQL schema based on any data, whether it's local, remote, it could come from anywhere. And since it generates a GraphQL schema, you can query that schema from your pages. And it's really cool because it basically infers the type of the GraphQL schema that it should generate by taking a look at the data. So it's another way of leveraging dynamic GraphQL. And so yeah, that's a bit of a thought experiment to maybe appreciate more the tools we use day to day as developers, because they do some really cool complex stuff thanks to GraphQL, the schema, and its type system. So having said that, I wanted to give you some tips and tricks and techniques I used to write that kind of code for some years now. As I said, I build tools on the side, and I'm going to give you an example of a tool just to show how you can leverage dynamic GraphQL. So it's called GraphQL Admin. It's a no-code UI for GraphQL APIs. So what I wanted to do is, like, you can point this web page to any GraphQL APIs, and it can create an admin interface for it, like tables and forms and everything. And you don't need to learn GraphQL. You just point it to the API, and it generates queries by fetching the schema. So that's how it leverages dynamic GraphQL. It fetches the schema, gets the top level query fields, shows that in the sidebar. Feel free to check it out if you haven't. And it generates a GraphQL query for every one of those fields. So you don't even need to know GraphQL. You can edit the queries, obviously, but it's really a great way of showing how to generate a query out of nothing, just a schema, a URL. So a couple of techniques I used to do that. And you could see them as almost general programming advice. So I also think that's really cool. And building tools gives you that experience. So how to write dynamic GraphQL. Go for the interface first. Like, you will write functions which should have clear inputs and outputs. You should leverage unit tests. They are really your friends in making sure things are working the way you expect. And if they are your friends, then types are your bodyguards, or like best friends. I don't know how to call them, but you should leverage types. And in this case, TypeScript, which really gives you a bunch of confidence that you're building the right thing. And finally, leverage GraphQL ASTs for the implementation. And I'll show you how in a bit. Now for the first part. Focus on the interface first of the function. In this case, we have a function that generates a query, like a GraphQL query, based on a schema and field. You can pass it some configuration, like what you want to create, if it's just scalars, just enums, just variables, or a combination of them. So it's really good to think about what it should get. In this case, the most important parameters are a schema and a field. And this whole thing about dynamic GraphQL may seem daunting at first, but you shouldn't worry about that. You should really start by the end result, and then you will get there. How? Well, you should also think about unit tests and types, and then write the body. And it's just iterating until you get it right. So let's have an example of a unit test for the function I showed you previously. As you can see in this case, we have some schema that we got from a JSON file. And then this test verifies that it generates a query with just object. So you can see here it's a basic example where you give a field, in this case, the asset field, and you tell it to generate a query. And then you expect that the query looks like this. So again, we're focusing on inputs and outputs and not about how the function works first. And yeah, just a tip, you don't need to hit external APIs on your test. You can just save their introspection result as JSON and use that in your tests. That's a good way of not depending on external APIs. So now that we have an example of a unit test, let's take a look at how types can help us build dynamic GraphQL, our bodyguards in this case. So as you can see, this function now has types for the arguments that it receives and for the result that it should give out. And as you will see, I got these types from GraphQL.js, which is the library you'll be using the most if you want to generate dynamic queries. And yeah, so it provides types as well as a bunch of utilities to create GraphQL queries and schemas. But in this case, if you're creating a schema out of your function, or if you're receiving, then you should type that because it really helps you not mess up with a lot of things we can mess up on our day-to-day creating these complex functions. And if you're creating queries, then you should return a document node, which is just the type that represents a query, but in memory. And having said that about types and in memory, you should leverage GraphQL ASTs for the body of your functions. You might be tempted to just create strings, which is good for simple cases. Like you could use string interpolation to create a GraphQL query, but you will see that that doesn't scale over time. So it's great to know the API of GraphQL.js and know what's an operation definition, a document, a variable definition, and that's how it represents GraphQL queries internally. So feel free to check out the docs, which are really amazing. Yeah. And yeah, so this is an example of a function that creates a document. And don't worry if it seems complex, as long as you have the correct types for your function and your tests verify the end result, you will get there. There are many different ways of writing these functions, and you will use your own style to get there. So I'm gonna get to the third part of this talk, which is really to encourage you to create these kinds of tools. Don't just be a consumer of them. And it's great to be a consumer of these tools. I am a consumer of these tools. They make our lives easier. The development experience that GraphQL enables is just out of this world. I'm so glad to be using them day to day, but it's also so fun to create them. So I really want you to go ahead and build the next great or small GraphQL tool, because they really improve our day-to-day development experience. So yeah, I'm so grateful for the people that do create them, and I really want you to be the next one. So thanks again for watching. Thanks to the organizers, and yeah, just wanted to invite you to next time I'm giving a talk about testing GraphQL APIs with my colleague Bruno at the next GraphQL Conf. So I'd love for you to be there. It's a free conference, so I want you to be there and enjoy all of the great talks by our community. And that is a wrap. Thanks for watching. I'm gonna stop sharing there. Hi again, guys.
Hi. Very nice talk. I really like, yeah, I really like because of how GraphQL works. Some of the tools, that have been the community has been able to, to build around that because it's really, really powerful. So I think guys can always, try to figure out how to build some nice tools. One of my favorite tools that I use is GraphQL CodeGen, especially when you're, writing like front end and stuff, because it's like a contract that you have between your server and your client. So you can be able to generate, type safe queries and or hooks just to get your data. So it's really nice to see this.
Makes your life so easy as a developer, right? To have the confidence of knowing what those functions return and how to use that in your code. Yeah, it's an amazing tool made by the guild, and they make a lot of awesome GraphQL tools. So props to them.
They are an awesome team. Great. Please feel free to ask any questions on the chat. I believe Julian will be hanging around, with us for the next maybe 30 minutes or so. So if you have any questions for Julian, check out some of the slides and the links that he shared. You can also reach out to him on Twitter. But thanks. Thanks.
Yeah. Thank you, Joey, for everything. And I'll be around to answer any questions. So.
All right. I'll see you back at the end of the talk. So moving forward, I think we're going to go to our next talk, or rather, is it a workshop where Mahmoud will be joining me, and we're going to build. A GraphQL API, and we're going to use Prisma to resolve our.
So this is more of a, I don't know, is it like live coding / workshop / hanging out? So feel free to ask any questions. So like the previous talk, which was great, it is advanced. So if you're not familiar with GraphQL, it may have been a little bit scary, but it was very interesting because that's how developer tools so like Julian showed us how a developer tool can be built on top of GraphQL. So it was really interesting. But now, if you do not have any experience working with GraphQL, then this talk / workshop / live coding / us hanging out is for you. So if you have any questions, there are things that you're not sure about, feel free to ask. Would be happy to help. So today, from what I understand, Joey, we're building a GraphQL API. So if you're someone who is primarily working as a front-end developer, you probably consumed GraphQL APIs or just REST APIs. So GraphQL APIs are a different way to build APIs. They have a lot of benefits. I'll be mentioning them as we go along. So like now we're building the backend. So Joey, do you mind sharing kind of like what exactly we'll do?
Yeah, sure. I'll be sharing a repo on the chat in a minute, but I'm just going to.
I'll share it. One sec.
Just going to go ahead.
So the repo is called Nairobi GraphQL Meetup, GraphQL with Prisma. Should be in the chat. And you should be able to see it. Is everything okay? You seem confused.
No, I'm just trying to share my screen. Just a minute.
Oh, yeah. Once you share a screen, we'll share it. And let me know when you're ready.
Just a sec. I have to just share this.
Okay, let's add it to the stream. And let me just update the nameplates. One sec.
Let me know if you can see my screen.
We're ready. Yeah, we can see your screen. Everything should be
great.
If everyone has any issues, feel free to comment down below. But otherwise, let's go.
Yeah, so this is the repo that we're going to start with. We're going to build an imaginary feedback service. Let's say we build an app and we want to collect feedback. So we want to build an API where guys can, just give us feedback, whether it's maybe they're experiencing any bugs, or they just want to give us, any general feedback. The main packages that we're going to, or rather the prerequisites, a general understanding of JavaScript functions, and a high-level understanding of the GraphQL spec, how you define your type definitions and resolvers. But if you don't know, we're going to have a look at this. No worries about that. Nice to have if you have experience with TypeScript, but it's not, like a hard prerequisites. The main packages that we're going to use is GraphQL and Polo server. This will be our server layer. And then we're going to use Prisma to interact with our database. I used, or rather the version I used for the node runtime is 14, but I think it should work if you have anything from 12 and above. There's also this nice VS Code plugin for if you're using VS Code. You can install it. It just makes the developer experience a bit better. So without further ado, I'm going to, here's the repo. Let's just have a look what we have here. This is the starter. I'm on the main branch. So we have 3 files. So this is where we define our type definitions. At the moment, we have just a hello, which returns a string. Then we have a resolver for our hello field, just returns a string as well. Then on the server, we just have, we're initiating upon a server, passing in the type definition and our resolvers. Then, we're just starting the server. Then if you go to the package.json, we have a couple of scripts. We have a dev script, which just starts the server. We can do that by doing yarn dev. So the first thing you want to do if you clone the repo is install the dependencies, and then you should be able to run a yarn dev. Then, we can click on here. Then have this, just go to the graphical interface. Fine, I can type. Yeah, so this is the graphical interface. It's an interface that lets you explore your GraphQL. So here you can write queries, and then you have some nice docs here. You can see some of the things you can do or ask for. So here we only have the hello thing, and it just returns a string for now.
Okay,
Great.
so one sec. So like this was a lot. So let's do kind of like a quick recap. So here, Joey showed us a quick kind of like hello world GraphQL API using Apollo server. And yeah, so like to understand GraphQL APIs, if you worked with REST APIs before, you have several endpoints, and each endpoint will accept like a type of request. It could be a GET request, a POST request, or anything. It depends on like your implementation. And yeah, so like with GraphQL, things are a bit different. So you have a single endpoint that you interact with, and you send a query. So Joey right now is highlighting a query. So this query, the query name is hello. And we know by looking at the type definition that this query will return a string. So with GraphQL, it's a querying language for your APIs. So it's a lot easier to understand what the API does, but when using GraphQL. So like, say for example, you're working with a REST API, and what happens is a new feature comes out. Like the backend developers change like a certain implementation. Maybe the endpoint now doesn't accept a string, now accepts like a number. So you wouldn't know unless you go through like the documentation of the REST API. But with GraphQL, you actually get that out of the box. So what Joey showed us, like this is the GraphQL playground. It is an easy way to just run queries and kind of like test them during development and see what type of data is returned. So you have the docs, and you also can see the schema. So do you mind, Joey, opening like the schema?
Yeah.
So the schema, it shows like the different queries that we have. The most important one is the type query. So with GraphQL, you have two things. You have a query and you have a mutation. So a query is kind of like a GET request where you're just sending a query, you're asking for data, and it's being returned. With a mutation, you're doing so like updates and deletes. So this way you have the same CRUD, create, read, update, and delete functionality with GraphQL. And yeah, so like you can easily just understand what a GraphQL API does by looking at the schema. And if you also go to the docs, so do you want to go to the docs? So in the docs tab, you can see the different queries that you have, and you can see what type of like, what is the return type of this query, what are the different variables that it accepts, and yeah. So GraphQL is just, it's really nice. Like I'm a huge fan, and I'm also a little bit biased, like Julian. But yeah, so like I personally am a huge GraphQL fan, and yeah, so like this is the Hello World API. So if you go back to the code, Joey, you have like just a server. So Apollo server, this is actually Apollo server version 2. So there's actually Apollo server 3 that just recently came out. And it's a little bit different than Apollo server 2, but the concepts are the same when it comes to creating your schema and writing your resolvers. So you don't have to worry about that. And actually, if you want, you can make an open source contribution to Joey's repo, and you can update the dependencies if you want. So you can just make a pull request. And if you've never done that before, I'd be happy to help. Joey would be happy to help to kind of like walk you through that, to just update the dependencies. Also, Prisma recently, just version 2.29 just came out on Tuesday. So you can also update that as well. And yeah, sorry, I've been talking for a little bit. I just wanted to recap everything that we've done. And the final thing that I wanted to mention is resolvers. So resolvers are the functions that will get executed when a query runs. So when we looked at the schema, it just said the query hello returns a string, but we don't know what this query actually returns. So in the resolvers are the functions that will get executed once we run that query. So here, this is the resolvers. This is the implementation. So here, Joey has the query called hello. It will return Nairobi GraphQL peeps. So if he changes that and he runs the query again, we'll get a different response. So yeah, if you want to try that, we can do that. And now we can start like actually building the API and adding more stuff to it. But yeah. So we just named it new value. We saved it. And if we run drum roll, is there an issue? Oh yeah,
I needed to restart it. So
yeah, so like now drum roll, if we run, we get new value returned. So yeah, GraphQL is awesome. If you want more resources, there's the How to GraphQL tutorial. If you go to howtographql.com, let me share that link in the chat with you. There are a lot of tutorials out there with different stacks. So if you want to pick a certain stack, you can definitely do that. And yeah, if you have any questions, feel free to reach out to any of us really, whether it's GraphQL, Prisma, anything. But yeah, so sorry I've talked a lot. I just wanted to establish a foundation so that everyone kind of like understands what's happening. And yeah, Joey, you keep on coding, and yeah, I'll keep entertaining the viewers.
yeah, thanks. By the way, I hope you guys can see my font is big enough. I've just bumped a bit.
I think it should be fine. Like if
Yeah.
anyone has any issues, yeah, I think it would be a little bit better if you zoom in a little bit to just one.
Yeah, something like that.
Okay, yeah, that's perfect.
Yeah, as Mahmoud has said, so the resolvers, they map with your type definitions, and if you look at the type definition and the resolvers, they somehow have a similar signature. So some kind of an object, if you will. So you have the type query, and then inside it, we have a field. And here we're just saying this field called hello will just return a string. So with GraphQL, everything is typed. You have to define what the value should be. You can have a string, and we're going to see other types as well as we move along. Then the resolvers is somehow similar, but now the field is a function. So it's a function, and then you need to return something. So here you can return something. Here just hard coded the value, but here you can go to the DB, fetch some data, and then return. As long as the data returned conforms to what you said it is. So here we just said it's a string, and therefore we need to return a string here. We cannot return, say, an object or an array or something like that. But we're going to see that as we move along. Yeah, so I think to begin with, we're going to define a user type. So a user type, this will represent a user in our system. So we're going to say user type user, and then we do it like so. Then we have, so this as opposed to this was a string, so this will be an object. So we are saying the type user is going to have these fields that we're defining in here. We're going to say it will have an ID, which will return an integer. Then we can say date created. This we can return a string for now. And the exclamation mark, this says that this field cannot be empty. For example, if we on our query, if we say ID, it cannot be now, for example. That's why we have this bang at the end. Then we're going to have first name as well. And we're going to have an email. It's going to be a string. Then we have this field. It's a Boolean. So we've seen an integer, a string. So the value of this will be something like a 1, and then this will be a string. This will be a string. But now this is another type, and this is like true false. This is a Boolean as well. So here we have defined a user. Then what we can go ahead and do is say, now we're going to return remove the hello string or the field that we have. Then we can say inside our query, we're going to return an array of users. So notice the brackets here. It's like an array. But here what we're saying is that, hey, this field users should return an array of this type. So it's like an array of objects, since this is like an object with this field.
Joey, just one sec. The chat pointed out that there is a typo in first name, like it's first underscore name. So yeah, I just fix that. Thanks, chat. Yeah.
Thanks for that. Good to see that the guys are attentive. Thanks
everyone's paying attention. So cool.
Yeah. Cool.
So can I just recap what we just did? So right now we're still working on the schema. So the schema, we haven't actually wrote any type of logic yet. We're just defining what our schema looks like. So we have a user type, and we added a couple of fields. All the fields here are non-nullable, so they cannot be null. That means when we're executing a query, we have to return something. And yeah, and then for the query type, we have users. So what will happen is previously we had a query called hello. Now we'll have a query called users, and it should return an array of type user. So, but like we don't know where this like array or where these where this data comes from, and that's what we will do in the resolvers. But yeah, anyway, back to you, Joey.
Yeah, so we have that. And then actually what we can do here is also add the exclamation here, such that here this field cannot be null. So it can be an empty array, but it cannot be null. So that's what we're doing here. So if I save this, our server is going to fail because we've changed our query and we don't have resolvers yet. So we've changed this field. So if we go to our resolvers, we have this field, hello, but we've changed this to users. So For now, what we can do is I'm going to actually just say sample user, and this is going to be an object. Okay. And then I'm just going to copy this stuff.
So now this is an example user. So like the date created, we made it a string. So I believe there might be an error.
Yeah, so I'm just doing new date dot to date string.
Oh yeah, oh, sorry.
That should be a string.
And then first name is Joey. Also add an email and actor. Cool. So like, well, what we'll do is we will use that as a user, but it's an array. So what will you do is just sample user, comma sample user, comma sample user.
No, I can just return that one user, I think. Oops.
Okay, yeah, but it has to be inside an array though.
Yeah.
Right. Yeah.
So if I say this, so and then here instead of returning dates, what I can do is just return sample user. Yeah. So this is an array that only has one user for now. Make sense? And then our server is happy. So now if we go here, our server starts. Yeah, so if I go here and then we go back to the docs, we can see our docs have updated. And now what we can do here is say this query for our users. And then this, the graphical interface has autocomplete. So what you can do is hit Control space, and it will show you all the things that you can query. Yeah.
So one thing that I have to highlight that is just so good about GraphQL is that we only got the data that we asked for. So if you remember, the user had a lot of stuff. They had first name, a last name, they created an ID, but inside Joey's query, we just wanted the ID, the first name and the last name, and that's only the data that got returned. So in a traditional REST API, you might have the same endpoint. What will happen is you will end up with like extra data that you do not need. So this is called the overfetching. And also you might run into the exact opposite, where an endpoint doesn't return all of the data that is needed. So what will happen is you need to make another request to like another endpoint. This is called underfetching. So yeah, like GraphQL is awesome. Again, I'm biased, but like it's just a personal preference. Yeah, so like that's also something that GraphQL solves.
Yeah, it's really neat, especially if you think about it. So you have different, clients that are consuming your API. So you have like mobile phones, you have desktop applications, and all these kind of things. And with design, maybe you have real estate to show a bit more detailed data. So you wouldn't have to build like two APIs altogether. You just build anything and everything that you can show, that you can possibly show. Then it's up to the clients that are consuming this API to request for only the things that they need, which is really neat. Yeah, and then of course another thing is that GraphQL is data agnostic, database agnostic. So for example, at this point, we are not hitting the DB yet. So we're just returning this data that is, hard-coded, but it doesn't care really where your data comes from as long as you return the type that you define. That's really neat as well.
So like some people are kind of confused when they first hear about GraphQL. They think it's like a database thing, but it's not. It's like for the APIs. So yeah, do not get confused with that. It's not a database technology. It is just for APIs. But, yeah.
Great. I think for now we can go ahead and define our next type. We're going to call it feedback. We're going to do the same thing that we did with the user. We're going to have an ID field. So this is where, or rather the type of our feedback. Remember, we are building like some kind of a feedback service. So this is where we're going to, this is the API that we're going to use for that. And we can have comments. What else? Yeah, and then we can have a feedback type. This can be a string, or so let's say we have a feedback, right? So someone wants to submit a feedback. Maybe they want to report a bug, for example, or maybe they want to say they have an idea on how we can improve our app. So we want to be able to have this kind of types, and then we can be able to filter by that type. If we want to see any bugs reported, we can filter by that. So we can use this field as well. Yeah, I think that's it. And then what we can do on our query, we can
So
say,
one thing that I would like to add before writing the query, you can write it as I say it. So for the feedback type, maybe a better way than to have it just as a string is to use an enum. So enums, allow me to link to the docs of graphql.org. So enums are very useful because you can specify that you have only, so like a feedback can only have only certain types. So we can just say it's a feature, a bug, or a comment. And what happens is, yeah, so like you have idea, bug, or other. So now what happens is if we try to pass in anything else, we should get an error, right?
Yeah. So if you specify anything else than this, it will error. And this is really good. You don't want to, have like data that's not, so helpful. You want to define, you have this, you can control what type of data that you want to collect. So if you have like some constraints, and if you needed to add any other, feedback type, you can do so here. So here I've just added the feedback type instead of saying a string. So we're saying this is a feedback type, which we have this defined on here. So it can be an idea, a bug, or other, something that doesn't fall in these two categories. And then on our query, we're going to say feedback is going to return a list of feedback. Because our server is complaining now because we don't have resolvers yet. If you go to the resolvers, again, we can do sample feedback.
So we have a question in the chat from Sanjay. I'm going to just show it. So there should also be a link between the feedback and the user, the customer ID on the feedback. What do you think about that?
Yeah, we are going to do that. I'm just taking it a bit slow, but yeah, that's the whole idea.
Yeah, so like every feedback will be associated with the user, and we're going to do that. Yeah. The people are just so excited they want this thing built.
Real quick.
Okay, so right now we're creating also static data called sample feedback, so we can test our query, right?
Yep. Then, if you remember, the feedback type was, let's just say other for now.
Or other, yeah.
Then here we can say feedback. Function that returns feedback. Then we can check this out. Yeah, now we have feedback. Right, so right now we have this data, but again, this is like it's static, but this is a good idea, a good start. But we also want to connect these two. We want to know who submitted this, bug, or rather feedback, and we're going to do that by, we're going to go to the type definition, and then here what we can do, we can connect the two types. So the entry point can be a user, and then inside that, maybe you want to get the feedback that they submitted over the course of time. And then on here, when you're querying the entry point being the feedback, you might want to know who the user is. So what we're going to do is we're going to add two different fields. So here we're going to say user, and then we're going to say that returns a user. So this user is this user type that we created here. Hope that makes sense. So in this field, we will be able to return a user. Then we can go to, so for the user, a user can have many feedback, so here we want to return an array of feedback type, like so. So this will return many, it can be one or more. And on here, for the feedback, you can only have one user. Yeah, if that makes sense.
So for the feedback, the user is required. So I think it makes sense to have to make the user required and feedback, right?
Yeah.
And for the user does not have submit feedback, so that's why we're leaving it nullable. Like it's fine if a user doesn't want to give us feedback, unless it's like enforced, like when they log in, they have to give us feedback. But other than that, this is completely fine. Yeah, nice.
Yeah. So now, again, to our resolvers, so we need to find a way that we can return this. Let's just have a look at this. So here we can say feedback, then we can say user is sample user. So if we go here, let our server restart. So here we have a user field, and we can query this. So you can see, let me just comment out this so that we can have a clear view. So here we are querying the feedback, and inside there we are also querying the user. So this would be the user that submitted this feedback, and you'd be able to see that on here. I hope that makes sense.
Yeah, it does. If you guys, if you have any questions, feel free to ask anything. if anything is not clear. Yeah, just I'm looking in the chat, so feel free to ask any question. Yeah.
Great. I think for now we can try to switch up and try to figure out how we can have some data. And for this, so for your resolvers, you will need some place to store your data and read from and return. So right now we're just hard coding this stuff, which is not ideal for, if you're building like a real app, you want some kind of database to store your data. And that's where Prisma comes in, or rather one of the options that you can use. So Prisma, so how would you, Prisma is more, it's more than an ORM. Maybe Mahmoud can try to
Okay,
describe Prisma.
so yeah, sure. So when working with databases, so first of all, there are a lot of types of databases out there. You have relational databases, document-based databases, like key value store. Like there's just so many types. But yeah, so like every database has its own use case, and like just has its own like benefits and like pros and cons or like trade-offs. So there are many ways to talk to a database. You can talk to the database using the database's native querying language. So for example, we'll be using, what type of database we'll be using, Joey?
For this example, we'll be using SQLite, so that because you don't need to set up like a database, but you can use Postgres, MySQL, another.
So
as well.
SQLite is a relational database. So that means you have rows and tables. Now, when talking to SQLite, you can send SQL queries. So the thing is, while you can do that, it may not be kind of like the best developer experience because you have to kind of do like a lot of context switching when kind of like working with the database and then like writing your backend. So like here, we're building our GraphQL API using JavaScript, but with the database to actually like do like send queries to our database, we'd have to just use another language. So yeah, it just slows you down. So that's where query builders and ORMs come in. So query builders, they use programming languages to build queries. There are a lot of them out there, but again, with query builders, you're still writing queries, but like using JavaScript. So you still have to think in SQL when using query builders. So like the final step, or like the final way to actually talk to a database is ORMs. So ORMs, they allow you to use just a programming language using kind of like functions that are like readable to interact with your database. So yeah, that's kind of like the value proposition of Prisma. Now, when working with a relational database, there are kind of like a lot of steps that you need to do. So first of all, if you're working with, if like you're working with, I'm just checking out the chat, GraphQL is weird, you passed definitions and so on. We'll cover the questions later. So with like with SQLite, you will send queries. So first of all, you have to model your database. So you have to define the different tables, the different kind of like relations between each table, and you also kind of will have to do like migrations, and then you'll have to write the actual queries. With Prisma, it's a lot easier. So yeah, like you can actually show us Joey, and yeah, I'll comment on what you're doing.
Cool, great. So the first thing we want to do is we already have Prisma installed on here, but what we want to do is instantiate Prisma. So Prisma has like some really cool dev tools or CLI commands that you can run, and then it can do some kind of scaffolding for you, get you started. And for us, we're going to do npx Prisma init. So I'm just going to run this.
Yeah, so the Prisma, and it's like Prisma here is installed as a development dependency. This is the Prisma CLI, and it gives you like a bunch of commands to kind of like just get started working with the database. And the init command, what it does is it actually creates a folder that's called Prisma. And inside this Prisma folder, you will find a schema.prisma file. So do you mind opening that, Joey?
Sure. So yeah.
Okay, so the schema.prisma is kind of like the heart of your Prisma setup. So here you're defining the different tables and the different relations using Prisma schema language. So it's inspired by GraphQL, kind of like the syntax, because as you saw, GraphQL syntax is kind of like very friendly. But Prisma has nothing to do with GraphQL as a tool. So it is a tool just for databases. So when you think about it, you will have your database, you will have your API, and from your API, you're talking to your database. You're doing that using Prisma. So in our example here, the resolver, inside this resolver, we will write like Prisma queries so that we can fetch data from a database and we can kind of like do our CRUD operations where we create, update, read, and delete. So yeah, that's how it is. So like here for our example, I'm guessing what Joey will do is we will need to define two models, right, Joey?
Yeah. So the first thing we're going to do is, so Prisma supports different dialects. So for this, you can use Postgres if you want, if you have an instance. But for this example, we're going to use SQLite, like so. And then SQLite uses a file. So what we're going to do is say our data will be saved in this file. So a file will be saved in the same directory on here on the Prisma directory. Again, so if you're using like Postgres, you'd have like a connection to your server, to your DB rather, and you can say my provider is a Postgres instance, and then the URL that you have on there.
So two things. First of all, are you sure it's not dev.db? Because I'm not sure. I have to actually check. So actually, if you guys want the link to the documentation, it's prisma.io/docs. So allow me to send that here. And yeah, so like, let's see, working with SQLite. Just to double check that, or we can just run it and see what happens. Yeah, it should be like dev.db. So the file should be dev.db. So like it actually gets created. So the .db is the extension. Or you can name it whatever you want, but like this will be the name of the database.
Yeah, either way.
Yeah, so like another thing is when you're working with another database provider, so currently Prisma supports PostgreSQL, MySQL, SQLite, Microsoft SQL Server, and there's MongoDB in preview. What happens is at this URL, there's this function called env, and what happens is so like before actually we change this to SQLite, we're loading the connection string of the database from a .env file, and it's been created by Prisma when running npx Prisma init. So in this .env file, you are able to keep secrets, things that should not be shared. Like for example, the connection string for your database. You don't want people to have that because, well, if they have that, they have your data. They can do whatever you want to it. So these secrets should be stored securely. And another thing is, like if you have the database connection string, it also should not be committed to like your Git history. So most likely you'll have a GitHub repository where your code lives there. You don't want the database connection string to be there. Otherwise, again, if your repo is public, or I don't know, like it's not secure to commit your secrets. So yeah, and in case you do, I believe you can't, like it stays in the Git history. So yeah, like just make sure to not commit your database secrets. Otherwise, you may run into trouble down the road. But yeah.
Yeah, you don't want to commit that.
Yeah, please don't. Like just the .env file is added to the .gitignore. So the .gitignore ignores files like in Git. So you won't accidentally just add it to a commit or push it to the repo. And when running npx Prisma init, it should add like the so like .env is automatically added to the gitignore. But yeah, anyway, let's define the database models.
Great. So the way you define your model is starting by the word model. I have this VS Code plugin that does like syntax highlighting and auto-completion for you. So here we're saying we want a model called user. And here we are just defining some of the fields or columns, if you will. And then, so here I'm saying this is an ID. So this would be, you can use something else, maybe a collision unique ID or UUID, depending on the provider that you're using. But we can use an integer for now. Then we can say date created, which is daytime. And then we can default to now. So here we're just defining our fields. Then the plugin does some auto formatting for you. This is a string. What else we have active? Yeah, great. I hope you can still see my screen. Let me just reduce this. So
Yes,
here
yeah.
So here we have defined one model, our user model, with these columns. Then we're going to define feedback. Then I think we have an ID. Created. So here we're just defaulting this to now. When the data is being created, it will just pick up the time and the date. Have a publish field. And this one we can default to true. Also default this for the user as well to be true. So have a feedback type. So a feedback type, remember on our GraphQL API, we defined an enum. So SQLite, I think it doesn't support enums.
It does not.
Yeah, but if you had like a Postgres or MySQL instance, you can define an enum as well on here. And then you'd get like validation out of the box for free, both on the GraphQL layer and on the DB layer when you try to save some value that's not permitted. So, but for now, we're going to leave this as a string.
So a couple of things. So we recommend that when you write your fields to use Pascal case, so like this is, I believe, what casing is this? Is it snake case? No, it's not snake case. I don't remember. So like when using underscores, usually so when generating the queries and for everything to work properly, we recommend using Pascal case where the first letter is not capitalized and the other letters are. So feed underscore type will be feed, and then type will be capitalized. But like it's fine. Like this will still work, but that's what's recommended. And another thing is, by default, all fields are required. So here, if we don't provide a feedback type, we will get an error from the database. So if we want to have something that is optional, we just add a question mark after the field type. So maybe, for example, I'm not sure. I think we need all the stuff. No, not so after the string.
Oh, yeah.
Yeah. So right now, now feedback type can be optional if we want, but depending on the use case and how you want your database to be designed, yeah, you would add optional fields if you want. But yeah, anyway, you can keep going.
Yeah. So we have a feedback type, comment, which is a string. I'm not sure if I have a typo.
What's the issue? It's like it's not auto formatting.
Yeah.
So do you mind scrolling to the top? Wait, in ID, int at ID, at default, this should work. That's weird.
I don't know whether it's, let me see. Yeah, let's just see. Maybe it's the plugin, but we'll see.
Maybe. So like I think it says there's an error of some sort. So like wait, do you mind doing like Control Shift P and then reload VS Code? Because sometimes that's the issue. Just type reload and it is the third one, reload window. So I don't know, sometimes personally I get like random errors, sometimes extensions don't work. So usually reloading fixes it. But like if it's not formatting, that either means there's a typo or there's like something that is like not written incorrectly. But from what I'm seeing, everything should be correct. So now if you try to, like I don't know which shortcut you use to format, but like if you try to save, it still doesn't do it?
No, it doesn't. Anyway,
Yeah,
we'll
it says
see.
cannot format. So wait, let's read it. Auto increment, that is correct at default, and it's highlighting. Why is it not working?
Anyway, let's
And
see.
like the issue is, yeah, we'll see. Like maybe it's just the extension. So when we try to run like a migration, we'll see if there is an error or not. But I think that's the extension. And
it did not.
Correct. Yeah, I'm not sure why or like why it didn't. Maybe that's I'm not sure.
Yeah.
But hey, it worked. You know, sometimes the things just magically work.
Yeah.
Anyway.
Yeah, so here we've defined two models. So here at this point, what we want to do is create a relationship between the user and feedback. So what we can do is say here on the user, we can say feedback, and then we're going to say it's going to be this. And notice what happens when I save. So I think this is what Prisma calls is it implicit or explicit relationship?
So here it's explicit, right? Because we're defining, like there's nothing happening under the hood. So here, what we have is we have a feedback. This feedback field is, so like for the user, we have each user will have an array of feedbacks. So like a user can just submit as many feedbacks as they want. And then each feedback is associated with a user. So it worked, but how? I'm not sure like why the extension did not work. And also like Daniel said, the extension wanted to keep things interesting. But there you go, like developer life, it's just like things just happen like that. Sometimes things magically stop working, magically keep working. But yeah, I don't know, maybe we can do like a bug report or something to understand why that happened. But anyway, so like here, when Joey hit save, what happened was the extension automatically created the relation. So like it's correct. And yeah, what I wanted to say, so like each feedback is associated with a certain user. And that's why we have this user ID. And yeah, so like in the feedback, you have a field called user, which contains the user, yeah, hashtag dev life. And for the user ID, it's just also an int. Now these are optional, but what we want is for them to be required because we don't want a feedback to not have a user. So I would just remove the question mark after user and after the int again.
Cool.
And things work. So yeah, now we have two models. These two models will map to two tables in our SQLite database. And we know that each one of these tables has a primary key, which is ID. So a user has an ID, which is unique. And also the feedback, each feedback has its own ID, which is unique as well. And we have a relation between the feedback model and the user model. Now, one thing that I'd like to mention is that the GraphQL API doesn't have to be a mapping like a one-on-one, like one-to-one mapping of your database schema. So yeah, you don't have to do that. This is just because our use case is simple. But yeah, you can define your GraphQL API however you want, and your database also model it however you want. But yeah.
Yeah, so you don't have like to expose everything. If you think about it, maybe there are certain fields that you're not exposing to the outside world, if you will. So your DB can have lots of stuff that you store in there, but you just expose what's needed, what your apps or clients need. But our use case here, it's a really simplified example, which happens to map to expose everything. Yeah.
Yeah.
Great.
So what are we going to do now? What's the next step?
So the next step we want to do is we want to generate a Prisma client. So, and we do that by running npx Prisma generate.
So one thing that I'm not sure about, if we run npx Prisma generate and we run the queries, do we not have to do a migration before? So like right now, the SQLite database doesn't exist. If we try to run the query, will we get an error? So I would like to try because from what I think is like, okay, how would we know that this will work? So I would say let's test it. And if we run into an error, we know that the issue is that we did not do like a migration and created the tables inside the database. And also one thing, if you want, yeah, sure, go for it.
Yeah, I think the DB doesn't exist yet. So one thing you can do like a migration, or you can do since we are on our local and we are just testing things out. Maybe you can do a DB push.
Yeah, definitely. But like, I just want to test like what would happen if we don't do DB push or run Prisma migrate. So let's just test it and see if we run into an error. We know like that with the reason. So yeah, don't worry about it. So like, let's write our resolvers and send like a Prisma query to see what happens.
Yeah, but right now it will definitely fail because we don't have our DB. It's clearly not here. So I think it will fail. So I think let's just do.
Yeah, sure. Like you can do npx Prisma DB push. So DB push is a command by the Prisma CLI, and what happens is it will grab your Prisma schema and will go to your database and create the same like model that you need. So usually you would do that with using SQL if you're working with a relational database, but you don't need to do that. So that's why you just run a command, and now you have the different tables set up with the different relations with all the primary keys and all that stuff. Right. And also it generated Prisma client for us. So you don't need to run npx Prisma generate on its own. So like it will generate the queries, but now it just got, so like this is the latest Prisma client. So like, because as your database evolves, you may not have the latest Prisma client query. So let's say, for example, we added a new field and we did not do like, and we did just npx Prisma generate, like things will be out of sync. So there's not really a need to run npx Prisma generate on its own unless you're like introspecting a database. So yeah, like The workflow, like if you're following along, you can just send, you can just use DB push to set up the database and all that stuff. But yeah, anyway, let's write some resolvers.
Yeah, I think actually even before we write some resolvers, I think I'd like to show Prisma Studio.
Sure. Like, yeah, so Prisma Studio is like a UI that allows you to view and edit the data inside your database. So we will be able to see what type of data is in like our SQLite database. And right now it's empty. So there are two ways to actually add data. So we can do this manually using Prisma Studio if we want. We will see that we can create a user and along with their feedback, or we can write a seeding script. So a seeding script, but like we don't have to do that right now. Like I'll link to the documentation. A seeding script is a function that we can run that will populate our database with data. So this way, this is really useful if, for example, someone is cloning the project and they want to have like dummy data inside their database. They can do that. So right now we don't have any users, we don't have any feedback. So let's create like a user and feedback. So what happens is you just open the model, you then click add record, and you fill in like the data for each column. Now the ID and the date created will be automatically added because the date created is just now. It calls the now function, which just returns like right now. And for the ID, it will be auto incremented. So this first record will be 1 once Joey hits submits or like hits save. And when we do another one, there will also be like number 2. So now we created a user. We create a user first because if we actually try to create a feedback, we will have to connect it to a user because in our Prisma schema, as you can see, it turns red. We have to have an associated user with it. So that's something you also need to be aware of when kind of like modeling your database, like which models rely on what exactly. And yeah, so like this is Prisma Studio, and now we have our database with data inside it. We have a user with like a feedback. So actually, I don't think you need to add quotes for idea. You can just make it capitalized and will be saved as a string since we defined that in our Prisma schema. And yeah, so like now let's just like recap everything that we've done because we've been running for quite a while. So in case you forgot, or maybe you joined a little bit late, we're building a GraphQL API. We went over the different packages. We went over defining our schema, and we went over like what resolvers are and how they work. And we also use Prisma, and Prisma is a way to easily just set up a database, interact with it. Like setting up a database is not the most accurate term, but like you can easily just send queries to your database and set up like the tables and kind of like the relations between each table. And you do not need to know like SQL when you're working with a relational database, or you do not need to use the database's native querying language. You can just use JavaScript or TypeScript. Here we're working in a TypeScript project, but if you're working on a like JavaScript project, there shouldn't be any difference. And yeah, and like we created a SQLite database because they're just super easy to just show what we're doing. You do like if you want to set up a like a hosted database for maybe using like Postgres or MySQL or Microsoft SQL Server, you would have to kind of like use like a database provider. No, not a database provider. Like you will have to just pay for the database since it will be hosted. Maybe the database is from like Heroku or something, and you'll get a connection string and you'll add it. And what else did we do? We did a lot of stuff in this live stream. And yeah, like we then defined like our models. So like we created our API, we defined the schema, and now what we need to do is just define the resolvers. So the resolvers, we're fetching data from a database here at SQLite. And what we want to do is just we set up the database, we added data in our database, and now what we need to do is open up our resolvers, send queries to our database using Prisma, and we should have a complete API. Now, yeah, I think to not make this super, super long, we can just show like reading data, and yeah, just go over it super quickly, and we can wrap up. Yeah.
Yeah, great. So right now I'm just gonna try to run over this quick. So right now we're just returning this hard-coded data, but now we have our models our database. So we want to return that data. One way we can do this, so when you're creating your server, we can pass in a context here. So context is like a way of sharing things within your resolvers, and they will be just available on all your resolvers. So what we're going to do, we're going to create a file here. I'm going to call it context, and I'm just going to cheat a little bit. I'm just going to copy paste. So the first thing we're doing here, we are importing the Prisma client. This is what was generated by Prisma, and this is a client that is somehow tailor-made for against our database. We defined our database, and it knows it has type definitions for us, and we're going to use this to interact with our DB, read data, and return to our API. So here, this is just a TypeScript interface so that we can get type safety and completion. Then we're instantiating a new Prisma client instance, and then we're passing it to the context. So we're saying the context is of type this interface, and then we have a Prisma field, which is mapped to the Prisma client. Then
awesome.
what we can,
Yeah,
so
what's the next step? So adding the context, right?
Yeah, so we can add context. We can import the context. Context. Therefore, this will be available on our resolvers. So what we can do in our resolvers. So remember we said the resolvers are functions, and it takes 4 arguments. The first one is a parent. So if you have like nested queries, so if you have like a feedback inside a user field, the parent would be the user field. For this case, it will be the query, since the query is the root query or the parent query. Then we have the second argument, which is args. So think of it when you have resolvers that take arguments. Say you want to get a user by ID. That's the second argument. And then we have context, which is the thing that we just passed. So what we're going to do, I'm going to say this is of type context, so that we can get that. I'm going to make TypeScript happy just to say this is any for now. So instead of returning this, let's just, so what we're going to do is we're going to say context.prisma. So now you see we have auto-completion. Remember, inside here we're saying the context should have a field, Prisma, which is the Prisma instance. So, and here what you want to do is say prisma.user find many. Since here we are returning many users. And what we want to do, we also want to remember it has the feedback. So we're going to say include feedback to true. So we're going to link to more documentation on this. But here what we're saying is that it should also return the feedback. And you can also, I think you can also define specific types if you don't want to return the whole columns on that table. You can select which ones you want. So this is an async function. So go ahead.
And we have to await the query. So like await context. Yeah.
So that's for the users. We're going to do the same thing for feedback.
I mean, we don't have to because like we just have D1 feedback, right?
Yeah, but let me just show that. But it's gonna be very quick.
So I just sent the link to the find many in the docs. You can check it out. It takes arguments, but if you don't provide anything, it will just return all users. But it would not have included the feedback, and that's why we added include feedback true. Yes. So like it's so like for the feedback resolver. So like in the schema, we define that user returns all users. So and for the feedback query, we're returning all feedback that is like in our database. So yeah, that's what we're doing. Now we're just sending a query, a Prisma query to the database, and the data should be returned. So now when we actually just when Joey finishes and we hit save and we go to the GraphQL playground and we run the query of like users, we should get an object called like we should receive an array of objects where we have just a single object where it's one user. So yeah, and like now after that we would have a complete kind of like a GraphQL API that talks to a database and fetches data from it. Now, if you want to maybe do like other types of operations, maybe you want to add feedbacks, will we be adding feedbacks? Will we cover mutations or will we just add the code to the repo? Is it part of the plan?
I think there's on the repo there's the code is full or rather it's done fully. You can feel free to check it out, but
Okay,
let's see
we'll
if
link
we
it.
can. Yeah. So if we go now to the playground, if I run this query.
Okay, if we run it,
oh yeah,
cannot return
user.
null.
Yeah, so I didn't include user in here.
Yes.
I think. And that's it. Let's see.
And let's refresh and try again. Should work.
Started now.
Okay, I think the server.
There's an error.
So let's try to debug. So like right now we're just calling the feedback ID and first name. So they should be included. Let's log the feedback and see what we're returning. No, a user is capitalized in your Prisma schema, so you should leave it like that. Like let's just log feedback and see what exactly gets returned. And if there is a mismatch, most likely there's just a mismatch between the schema. So like we can just update the schema and see what happens. Yeah. So now if we just hit save and we run the query again, we'll be able to see kind of like what is this feedback that we're requesting. So let's just do a full refresh. Oh yeah, okay, so now it's running. And if you go back, you should be able to see, okay, now we actually see the data that is returned. We have an array of objects where the object has a user and all that stuff. So what is the thing that we're not including?
Let me see.
Yeah, let's go to the docs or like the type definitions.
Yeah, it's a mismatch with the type definition.
No, so they must match. So if we go to the feedback one, there's feedback not user and it's required. But yeah, let's just remove the required field and see what exactly gets returned. Because right now, that probably means that we're returning something null. So like, let's just test and see what happens.
Let's see.
And if we go to the GraphQL playground, it's starting. And looking at the log data, we'll be able to see, okay, why is this not even included? Okay, so user here is null for a reason. And I'm guessing, yeah, so I think I know the reason. You should rename the type definition in your schema to user that is capitalized. So in your feedback type, make the user key also capital. Like, yeah, this one.
Yeah.
Because it gets returned from Prisma No, that's like in the feedback, make the key user, just capitalized. So yeah, where you were. So like the schema, so like the
So
issue is
yeah.
so user capitalized user. Yes, this should work. And make it even required, it should return. So like here, this was kind of like, and I think this is a bug that I reported in the Prisma extension, that when it autosaved, it made the field capitalized, like the model's name. And what happened is that you're referencing in the schema user in like lowercase. And if you go to the return data from the previous query, the user is like, it's not the same key. So like that's why it returns null. So like right now, if you test it, it should work. And if I'm right, I don't know, like send like claps and stuff in the chat. It did not work. Okay. Did you
Did you
mean
mean
user?
user?
So
Yeah.
wait, did you refresh?
Yeah, I did.
Like the server is at the latest? That's weird. So like cannot query field user on type.
So here also it should be user.
Oh yes. Yeah. Now it should work. And now I should get like claps and high fives in the chat.
Yeah.
Yay, we
Yeah.
fixed it. Yeah, so like that's something to be aware of. So that's kind of like I would say, the challenges of working with GraphQL at first. If you're not using any tooling that helps you generate all that stuff, you might run into these issues. So like there's type GraphQL, which is a framework you can use to generate all that stuff, if I'm correct. And yeah, so like what happens here was there was a mismatch between the return data and our schema. So this is good because in like locally, we know that there's this issue. But imagine if like we did not have that from GraphQL, this kind of like type safety, we would have like it would have just have not worked. Maybe we just would have got like null, maybe data will not be rendering. And yeah, live debugging for the win. Yay! Thanks, chat. Thank
Yeah.
you.
Great.
Yeah.
So I think right now what we've done is I don't know if I don't think we have time to show like mutation, but if you check out like on the repo, we have examples of mutation, how you can add data to the database via the GraphQL API. So check that out and try to play around with it. Build your own
Yeah. So
stuff.
like it's the same concept. So like the difference between a query and mutation is that in your schema definition is just a different type. And for mutations, so like it's a convention. So theoretically, you can write like query logic, like you can have resolver that returns data, but like doesn't do a mutation. Like you can do that, but like the convention when working with GraphQL is that if you want data that is returned, so like you're reading something from the database, you should use queries. But if you want to make any kind of like updates or deletes or creations, you should use a mutation. But the logic will be the same. You will just create a new type. It's called mutation. You will also give this mutation like a name. So here are queries. We have a user's query. We'll also have a mutation maybe called add feedback, create feedback, depends on how you want to name it. And this mutation will return also a feedback, but it will just return one feedback since that's the one that is created. And then in our resolvers, we will just add a Prisma query that like creates a new feedback. So like, for example, add user also works like that. And yeah, so like, I guess we can wrap up, but before doing that, I want to go through kind of like the comments and like see if there were any questions that I did not cover. So in the beginning, I'm not sure how to pronounce your name. Yeah, I'm not going to. What's your name? But yeah, you were asking, what do you folks think about GraphQL and Nexus? I think you don't mean GraphQL. But yeah, so like GraphQL and Nexus. So Nexus is a code first, like it's a schema construction library. So like right here in our example, we wrote so like this approach. It's called schema like SDL first. So we're defining the schema using GraphQL schema definition language. And as you can see, it's like it works, but we're writing everything ourselves, and there is no auto completion because it's a string at the end of the day. So like the types and the object types, all that stuff, it's a string. So you don't get the auto completion. But with Nexus, since it's like a schema construction library that uses code to do it, this is a code-first approach to building your APIs. You get like things like auto completion and also like some type safety. So maybe in your like I don't know, like in a mutation or a query, if you use the wrong types, you will get like errors saying like, hey, be aware, you shouldn't do that, which makes development a lot easier. So like here, for example, we run into the issue of like there was something that was incompatible between the data that is returned and the schema. If we were using Nexus, we would have gotten an error that says, hey, the return type does not match the schema that you defined. And another question that I wanted to cover. Okay, Nexus is sprayed out as well. I mean, awesome, that's cool. Thank you. And then the last question / comment was GraphQL is weird from Peter Spari. GraphQL is weird. You pass type definitions and resolvers when creating server instead of IP address and port. So I believe this question is, so like when you compare the hello world of a GraphQL API versus the hello world of a REST API. So for example, when using Express, it's a bit different. So like with Express, you can define just an endpoint that like accepts GET requests, and when you go to it, you will just return hello world. With GraphQL, you kind of need to have a schema, you have to have resolvers, and you have to have your own like GraphQL server. So that's kind of like the trade-offs, because like with GraphQL, we added a lot of information about our API. So we have information about like what type, like what are the different queries we can run, what are the different mutations. With like something that is like a REST API, you don't get that information unless you write documentation, and documentation can become out of sync. That's why for REST APIs, you might have different versions, and maybe also when like, I don't know, an endpoint, like it's also not strongly typed. So like here, we got like errors when you passed in the wrong types of data. So for example, with a mutation, we will pass like variables to create a feedback. So we will pass the content, we will pass the user ID and all that stuff. And if we pass something that is of the wrong type, we should be getting an error as well. So yeah. I think.
And also, I think also,
everything. Yeah.
Yeah, just to add to that, on REST, so you'd have like different endpoints. So you'd have like /user, but for GraphQL, it's just one, you'd have like one endpoint, like /GraphQL, and that's where you do everything. You just need to query the data that you need, and you only get that. With REST, you have to keep up with, all these endpoints. Yeah.
So one last thing is the raffle. So
yeah.
Now I don't think that I have access to the response. So the responses of the form. So I won't be able to kind of like pick someone live. But if you win, I will email you, because we asked for the name and email. So yeah, thank you so much for sticking around till the end. And yeah, I guess we can wrap up.
Yeah, so thanks everyone for tuning in. Be sure to check out the finished code. It's on the final branch, I believe. Yeah, play around. Feel free to check out the Prisma docs. Reach out to myself or Mahmoud if you have any questions. And yeah, thanks.
Yeah, thank you so much for hanging out. And yeah, we'll see you online. Feel free to ask any questions. And thank you, Joey, for organizing all this stuff and like presenting and doing all this stuff. It's been really nice and informative.
Yeah, also big shout out to Julian. I don't know if he's still hanging around. Nice presentation. Thanks.
Yeah, it was really nice. But yeah, anyway, thanks everyone. I think there's just one final comment. We should do this more often. Thank you, Daniel. I agree. So like, I would love to for us to have more events and for us to hang out and do like all this live coding type of stuff. Yeah. So anyway, thank you so much, and yeah, we'll see you online. Bye.
All right. Bye.